is on a web services platform. And occasionally I do get involved in these kinds of presentations where I can present features or functions on the AWS platform. As Katrina mentioned, today it's going to be all about some new features in the identity and access management realm of AWS. And it's going to talk a lot about how you can leverage some new features in that realm to actually extend your Active Directory identities and use them as a way to authenticate and then generate tokens to use AWS services. But with that, I want to jump into a presentation and give you a quick agenda of what we're going to cover this month. So I can imagine that a lot of folks may not even be familiar with identity and access management as a whole, so I want to make sure we go through a quick refresh of Identity and Access Management, or IAM, as I'll shorten it throughout the presentation. Then we'll jump into a quick discussion of temporary security credentials, what they are, why you might use them, and I'll sort of show that in the presentation. How you might wire that all together, all the different components might play together in a particular solution to allow you to do federated identity. And then I actually have a demonstration, an architecture and a demonstration based on a sample that we shipped with the new temporary security token or security credentials feature that shows how this all could be wired up. And I'll be doing that on some Windows servers in AWS to highlight that whole mechanism. With that, I'll just jump right in. So let's do a quick refresh of identity and access management. So what is identity and access management? So when AWS first started, the credentials, there was one set of credentials. There was there was your AWS Access Key ID, your secret key, and that was the master credentials associated with your account. Obviously, there were lots of questions early on about, well, do I share this set of credentials with all of my developers? Do I share this with other people in the company who might want to access AWS Management Console or the services directly? And the answer was, well, that's the way it is, when we started. However, that's why we created this identity and access management realm of features. It allows you, underneath an AWS account or a master account, to start creating and managing users and groups. Right? So you can create your own groups underneath that. So you might say, I've certain folks in the organization that are administrators. They have, there's one group for them. There's a group for my developers. There might be a group for my DBAs. There might be, various groups within my organization that might have different needs to interact with the AWS platform and different AWS services. Within those groups, I can create individual users. So I can create either a flat user in no groups, or I can put them in various multiple groups. And that allows me to sort of organize who belongs to what groups, and that actually will organize what permissions I might have. Because you now have the group and user infrastructure, you can actually have much improved security over the original single account credential model. You can create, obviously, multiple users. Each one can have their own set of permissions, which means you can create a policy for each group or actual individual user, and the combination of those policies will be their permission set. It's obviously secure by default. All of the APIs are secure, the storage of the information is secure, and the endpoints that we provide you are secure. And this also means that now you have the ability to create credentials for each individual user, so you don't have account identity sharing or credential sharing. So that means that if an individual joins the team, he's on your development team, you put him in the developers group under that group within Identity and Access Management. Over time, he might move on to a different group, or he might decide to move on outside of the company. You can deactivate that single account, or you can change the permissions of that single account. You have much more fine-grained control over the user's access controls and what services they can reach out and interact with. Again, it's part of that whole improved control platform. It's much more centralized control of user access. You can do this all within the console, and I'll show that in a moment. You can define fine-grained permissions. So as I was mentioning, the policies you can create that a group or a user level can lock things down to a specific API within a single service and a single resource in some scenarios. So that would mean that you could literally create a S3 admins group, and all they would have the right to are call the S3 APIs. And then within that, you might say, and this particular user only can access a particular prefix within a single bucket, for example. So we'll show some of that as we go along, and that's part of the demo later. But you really can lock down control to individual APIs, and in some services like S3, even down to specific resources like files within the actual S3 bucket. And then, of course, that allows them to get access to not only just the APIs, but it also works with console as well. You can generate identities that allow those users to log into the console, and then they would have access to, in that previous example of the S3 admins group, those users in that group would have their own logins to the console, which would then be restricted to interacting with the S3 tab, if you will, on the management console. They might be able to click on the other tabs, but they won't be able to interact or do anything with those other services because their access control policy limits them specifically to the S3 set of features in that example. And obviously, in order to support this, you need to create policies. We do have a policy generation tool, which allows you to, pick the APIs you want, highlight the conditions of access, indicate the resources they might be able to touch, and then that will actually auto-generate a JSON document, which you can use with the IAM console page to go ahead and set policies at the user or group level. And obviously, this is fully integrated in the platform, which means that you can create those policies in the IAM page, and then it immediately is impactful within the services integrated with the IAM technologies. So, that would mean that you can create a policy around multiple services to affect their EC2 usage, S3, RDS. All of those services are integrated in this platform and many more, allowing you to create one centralized policy that actually can manage access across multiple different AWS services. So let's take a quick look. This is some quick screenshots, but I'll just jump in and actually show you live right here in the console. So this is, my particular management console, and I've jumped here to the IAM tab. And so you can see here I'm on the last tab on the console there, AWS IAM. And I can now see that I can go right into my groups. I can see what groups I've created, and of course I have several groups that I've set up here previously: network admins, developers, script users, system administrators. So for something like system administrators, I might set a high-level policy on something like that that says, well, I want everyone in that group to have access to everything, and so I can actually show the policy right here in the console. I can see that my statement is that I allow access on EC2, S3, RDS, simple notification service, auto scaling, and elastic load balancing to any resource. So that's my admin policy. It's generic. It allows any user within that group under IAM to have that level of access, right? And then, of course, if I look in here, I see the sysadmins group has one user in there. I've got one user who's sysadmin. Now, that sysadmin may have his own additional policies. Obviously, it's a least permissions kind of a model, so he couldn't necessarily extend anything beyond what he got before. But he might have a specific policy. In this case, he doesn't. To obviously simplify administration. For the sysadmin, he doesn't have his own policy, but I could go ahead and set his own permissions by attaching a user policy right here in the console. Obviously, this applies to the other groups. Some can be less or more complex. As an example, say the developers group. I've decided with developers, I want them to be able to launch instances, add storage, create snapshots, but they can't stop instances, they can't delete volumes, they can't. So I went and created a policy that was very specific to the APIs that were much more read-only or additive in my environment relative to, say, APIs that might actually stop servers. So, it actually is a very flexible policy language that allows you to go ahead and add a whole bunch of distinct APIs if you want. Or do something more in sort of a star notation, like for SimpleDB, I've said, hey, I'll let them do everything, for example. So there's things like that. It has that flexibility within the actual policy language. So that gives you a sense of what IAM, the console, does and how you can manage those policies directly. Now, if we go on to what this means for an enterprise or for a large organization or somebody who already has an extensive user base, you may say, oh, well, great, that's fantastic. So given that model, what I can do is I can take all of the, the identities that I have in my company, and I can create, identity and access management users for them. And those then will show up and have their own user account that will allow them to access the AWS Service APIs directly. That's really, obviously a very powerful feature. It means you can have, one entity for, any of your developers to allow them to authenticate against the AWS services. However, there are scenarios where that doesn't work, and that certainly is a scenario. There are a couple specific ones that we've heard from our customers that actually this wasn't perfect for. The first example was, hey, I've got Active Directory, or I've got some LDAP store or some identity system, in place. It has tens of thousands of employees in it. Why do I want to create a one-to-one mapping between all those and the identity and access management platform? I want to use my existing identities. How do I federate my existing identity store into use AWS? That was certainly one early scenario that people came up with and said, hey, we want that too. Another one that actually has come up quite often is, I don't want to create permanent users. I really just want a temporary interaction. So I want to hand out a token or a credential or something to a mobile client to access, SQS or SimpleDB for the next hour or two. Right, so I want to be able to control that, fine-grained access control, but I only want it to last for a period of time, and I don't want to be creating and uncreating, identity and access management users all the time. So both of those weren't easily addressed by the previous scenario. So to address that, we went ahead and actually created temporary security credentials, and that's what most of this presentation is about. Really, the idea of creating credentials that you can use on the fly. So, some really common use cases I just mentioned. For something like this, obviously identity federation. So if I have an Active Directory baseline, user base, and I want to go ahead and federate those identities, so that I can use that username password that I have in my corporate domain as a way to authenticate and then get credentials to AWS. Temporary security credentials can address that. We'll see how that works. Mobile and browser-based apps, obviously, flexible, time-bound. Credentials that can be generated on the fly, handed out without worry of those being permanent credentials they might use later. They'd be time bound as well. Consumer applications with obviously unlimited users. So if you have several million users downstream, you may not want to create several million individual identity and access management users. You may say, let's just generate a token for it. So obviously this security credential model is intended also to scale much higher than just creating individual users, so it can scale to millions of users with very limited effort. What it contains, what's part of this, what you really get with it, is very similar to what you have when you create an IAM user. You set identity for authentication, and it actually has an access control policy. So that identity for authentication includes obviously an AWS Access Key ID, a secret key. That can be used for authentication, and an additional field that's been added, which is a token. Those three together represent the temporary security credentials that have been generated, and then as part of that, when you create them, you also pass in an access policy that says what features and functionalities you want to allow that credential set to access under the identity. So obviously it supports AWS identities, so the master account can generate these, but even IAM users that you've created underneath your AWS account have the right, if you so choose, to generate these tokens as well, these temporary security credentials. So how does that look? So if I were then doing identity federation with this new security credential set, I could go ahead and have my enterprise employees authenticate against an internal session proxy that would then authenticate their Active Directory identities, username, password relative to the Windows domain. It would then look that up in the local Active Directory store, and then it could call out these new APIs to get a token set for that particular identity. So a session could be started, and then those credentials could be handed down to the enterprise employees, who could then use them to call the AWS service APIs directly. So that flexibility exists to generate on the fly an identity based on authenticating against not the AWS authentication platform, but rather your session proxy and internal Active Directory set. The same thing could be applied, obviously, with mobile or consumer applications. Hundreds or thousands or millions of users downstream, mobile devices. They could then call a session proxy or a session service that would authenticate them against any alternate, identity store. So this could be just a username, password in a database that you protect. It could also it could be Kerberos. It could be other technologies that you might choose behind the scenes. But ultimately, it's obviously authenticating against that identity store, and then a credential set again is generated specifically for that device, that user, for that period of time with the control policy you specified. So what's in this new federation feature set? So obviously, it's enabling support for identity federation being one of the key scenarios that we've heard about for either enterprise applications or mobile or consumer apps. And then it's obviously going to support the support of this will actually roll out over time. As you see, the list here: EC2, S3, SQS, SNS are supporting this service right away with things like SimpleDB following the first line. So there's definitely service will be adding this feature set over time, but the generic feature set is in play at the moment. And so in addition to that, we've also provided a sample application, which is part of the launch that you can then download and sort of see how these things work. And I'll show you in the demo, I've actually extended that sample application for a slightly different take on how you might choose to implement this particular approach. What's important to realize when you think about what this permission structure looks like is that you're generating really a hierarchy of permissions, for the users that you're handing out these credentials to. So when I go ahead, the master account credentials that everyone gets when they create their AWS account are effectively unlimited. So you see, the permissions is unrestricted access to all the enabled services. So any service you've turned on, it gives you full access to it to call those APIs. Effectively in the AWS policy language, which is implicit here. Obviously, that's the action. Any action it allows any resource. It's full control, right? And that's obviously an implicit policy at that master account level. As you create IAM users, they actually get restricted by group and user level policies that you might set. So specifically, you could imagine, oh well, I want an IAM user that only has access to S3 full control and can generate, maybe generate tokens for others to go ahead and actually allow some level of access to S3. So I have an access control policy that's here, a small example of it that shows, oh, I can call any S3 API. And I can call the new session token service get star, so I need the get operations, which would allow me to generate a token set for a federated identity user, and I allow that, and it is on any resource. Now, what's interesting to realize is these temporary security credentials that you're generating. If you're using this IAM user, you're actually restricted immediately at that point by the capabilities of the IAM user that is generating those credentials. So, if I were using in this model or this example set that we're going through right here, that means that if I wanted to create temporary security credentials here at the bottom, I couldn't allow access to EC2 in this temporary security credential set because the IAM user I'm using above only has access to S3 and the ability to generate tokens. So it's actually further filtered. So that means I can do a finer grained restriction in my temporary security credentials, so I can restrict them further to just do get operations, and it's only to allow, and I can further restrict to specific resources underneath the star, but I can't expand that feature set with the temporary security credentials. So that's a really important model to recognize, that if you're using this approach to federate identities, you're not stuck with handing out the keys to the kingdom, and allowing any access. You actually can even make your session proxy, which is generating these identities, be restricted down to the singular services or features that you have to federate out. So you might not allow that federation, that session proxy identity, to do anything beyond limit the access to only the services you want those federated identities to access. So how does this all hang together? So here's actually the use case for the sample code that's in place. And here you can see the enterprise employees are on their laptops sitting around deciding they want to access S3 because they want to go ahead and have a backup folder that they can actually put things into, and they have a backup client on their laptop that they might be using to do that backup, but they can't hit S3 directly until they have a set of credentials for them to access it. Furthermore, the enterprise may say, well, I want everyone to be in just one bucket. I can only create 100 buckets under my account. So I can't, for my 10,000 employees, I can't have a single bucket per employee. I want to use a prefix before all their files per employee that allows them to say, okay, well, Bob's goes under my bucket /Bob, and Sally's goes under my bucket /Sally. That means I want to further restrict the access of that client on Sally's laptop to only the folder or the prefix that is /Sally under that bucket. So I can then control who can put what where, and I can further restrict the resource access. So the employee in this scenario would log in with their credentials to an enterprise reporting application, right? That enterprise reporting application will go ahead and obviously authenticate them against their identity broker. It will go into the identity broker, pass them those credentials. That would then authenticate against LDAP or Active Directory, whatever the identity store is. Confirm that in fact Bob is in fact still an employee, still works here, still has a valid identity. And then that identity broker down here can then go off and call the security token service and ask for a set of credentials that allow Bob access, Bob's identity access specifically to S3 and the folder /Bob under my bucket. So you can generate a policy on the fly and then go ahead and hand out that credential set to the enterprise reporting app and then also down to Bob. Bob could then go ahead and through that credential set call S3 directly and go ahead and actually upload a file, list the contents of his particular folder. Things like that will be allowed so that Bob can go ahead and actually upload, manage his files directly without having to go through the enterprise reporting app. And his backup client on his computer can go ahead and take care of that. So that's a particular sample scenario, and in the sample code that was shipped with the launch, you'll see kind of a basic shim that sort of lays that together. What I want to do was actually go one step further on that sample code. So the demo that I'm going to run through and show you is actually going to be this general architecture. Number one, obviously it's specific to Active Directory because obviously it's a very common enterprise identity store. Obviously then in that case using IIS. And the scenario that I'm going to run through in this demo is that I want to allow a client program down here at the bottom of the screen to go ahead and upload files to or read files from a specific folder in S3 based on his domain identity, right? So the first thing he's going to do is actually make a request out to an IIS server, which is where this session proxy service lives. And this is based on the sample code that shipped with the launch. So that server is actually running a Windows Communication Foundation service, which actually has integrated Windows authentication on it, which means that in order for him from that client program to even talk to that service, he has to then pass his Windows credentials, which means he then has an authenticated connection with that IIS server and that Windows WCF service. That Windows authentication, that Windows identity is then further used by the service to then look up his information in Active Directory. Within Active Directory, the one thing we've been talking about in this presentation so far is the idea of storing policies or sub-policies or more restrictive AWS policies based on these credentials. So I need some place to store those policies. In the demo code that you can download with the launch, it puts those policies directly into the web config of the session proxy. I chose in this particular demo to show how you can put those policies specifically into Active Directory. So with just adding people, with just group membership, adding people and removing people from a Active Directory group, you can enable AWS access. I'm going to show how that works in just a minute. But the IIS server and the WCF service needs to grab that policy information. So it reaches out to AD. It grabs all the bits of policy from Active Directory. It then generates a policy from that, from those bits of policy, and sends that along with a request to the security token service, the IAM APIs, which actually it generates a set of credentials on the fly for it. The IAM service then returns those credentials set, which then goes back to the WCF service, which then hands those credentials down to the client program. So now the client program has a newly minted set of AWS credentials that allow with an access key, a secret key, a token, and a specific policy tied to that, which they then will use to call AWS services directly. So now that client program can use these newly created credentials and call S3 directly and then list buckets and actually read files based on the prefix of their user identity. So I'll show how that all hangs together right now. All right, so the first thing you want to know about is what are we doing with this policy storage. So what I have here is I've actually brought up a Windows server. Obviously, easy place to demo something. I brought up a Windows server in EC2, and I've enabled it to be an Active Directory controller. I made a fake domain controller, Enterprise DC, that actually is running Active Directory. And just to simplify my number of moving parts, I installed IAS and enabled IAS on it as well, so that I could do it all in one box. In a production scenario, as seen in that previous slide, obviously the IAS server would be distinct. Most people don't run IAS directly on their AD, but that is obviously what I've done here, just for the simple approach. So if I pull up my Active Directory Administration Center, I can see that I have obviously access here to see the various groups. And what I've done is I've created a whole new group called AWS S3 users. The reason why I've done this, and I've added, I can add various members to it. So I have a couple of domain accounts here. I have the enterprise, the administrator of the enterprise DC domain. I also have just a standard domain user that's also part of the domain. They're both members of this particular AWS S3 users group. In addition to that, I decided to leverage some existing fields in Active Directory to store certain information. Now, in this particular example, I chose to just use alt security identities field. Because it turns out there's obviously a lot of fields within Active Directory, some which have purposes, some which are there just as placeholders. And it's, obviously extending the Active Directory schema is not something most people would be comfortable with doing or would even be allowed to do from a security perspective. So there are a lot of scenarios under which Microsoft products and even people who want to extend or use AD will just use or reuse Active Directory fields. So fairly common practice to take an empty field in Active Directory and repurpose it for certain scenarios. In this case, I chose to use the alt security identities field. There's also various other fields like URL or you can pick a whole bunch of things that might be interesting or unused at the time and use them for storing bits of policy. So as you can see here, what I've stored is not a complete policy statement. It starts right away with just a SID. It's missing that first statement fragment at the beginning. So I'm storing actually a portion of the policy. And in this case, you'll see here, it's kind of hard to read in this particular scenario, but I have a personal bucket access policy that allows the action of S3 get object to be allowed to the resource. And I've restricted it from a resource perspective, and you'll see I have a couple of odd strings in here, bracket, bracket, bucket name, bracket, bracket user. These are being replaced on the fly by the actual session proxy service, and I'll show that in a moment, to match the actual identity of the user who's authenticated against the WCF service. In addition to that, then I have a general bucket listing function which allows them to list bucket, and that is then allowed for the entire bucket name. So they can list the bucket, and they can go ahead and they can actually get a particular file out of that bucket based on a prefix that is connected to their particular username. Okay, so that's a bit of policy I've stored in there. Obviously, if I had multiple groups like this, EC2 user groups, various other services or even other functions, I might have fragments of policy in various pieces, and then this session proxy, I'll show you in a moment, can actually aggregate those policy fragments into one generic policy as a whole. This is obviously one approach. I want to stress, obviously, that this is only one of many approaches for storing policy. Policy fragments should be considered highly secure pieces of information. Obviously, they control AWS access. So even though it's not a set of credentials themselves, these fields should obviously be secured against change from unauthorized users. If you stored it in the web config as well, again, securing those. There's lots of approaches you can choose, but obviously these are highly secure bits of data you want to make sure are secured in your approach. So that's how you might store a bit of policy in Active Directory. In addition to that, I might want to pull that together. So I'll show you the code for the proxy that pulls this out. So one thing that's going on in this code is I obviously have a service that's being called to go ahead and get the token credentials. And so you'll see here, right in the middle here, I call get token. This is a WCF service that enables the requesting of the tokens. And so what I can get is, because this is a Windows authentication integrated approach, the logon user identity is available in the actual request itself. So you can pull out through an authenticated request that this is the true identity of the downstream client program that's actually calling the service. And then I can go ahead and get the security token for that username. What that eventually gets into is calling the creating the security token service, creating a security token service client, which you do here. Now, this set of credentials is different than the credentials I'm about to create. This is the identity and access management user, the IAM user. I'm using to call the IAM service, so he has, at a minimum, more than the credentials, or more than the access I'm going to allow to the generated token. But he's been restricted to just S3 and calling the secure token service. So this is actually stored in the web config, those credentials. So I create a client for that. I go ahead and build the username to make sure I pull the information out, and then I actually build the AWS policy. Now the AWS policy, this is where I'll show you how I get those bits out. With the AWS policy, I can actually use the user principal. It's actually passed in based on the username. So I can hit Active Directory, because this IIS server is a member of that domain. I can hit Active Directory, and then I can go ahead and find the identity for that particular username. Right? Once I have that identity, I can literally walk through, by getting the underlying object and using the directory entry class, which is part of the directory services namespace. That allows me to actually walk through the LDAP field, and I can pull all the various, if it contains, the AD policy field that I'm using, I can pull that information. Now, the AD policy field I'm using in this case was the alt security identities, and I put that in the web config, so it simplifies my configuration. But I can pull that. And so if there's actually something set there, then I can use that and consider that part of my list of AWS policies, which I then will add that string. I then can, additionally, I can get actually all the groups associated with that user, and then I can walk through the various groups and do the same exact check to say, hey, is there an AD policy field on that group? If so, let's add it to the list of policies that I have access to. And then at the end of that, I can go ahead and build a policy statement. So you'll see here, I'm basically starting a policy string with the slash, the curly quote, statement quote. And then I'm building out, and I'm actually extending for each of the AWS policy strings I found in AD, I'm going ahead and appending it to a longer string, which is then the complete statement of all access control capabilities. And you can see, as we talked about before, I'm doing some substitutions along the way. Things like bucket name should be substituted with the bucket name that I've configured this for. Domain and user can be replaced as well. And then I go ahead and put that whole string together, and that generates my policy. That policy is then actually used right here after I've got it to get a get federation token request to create one. And you'll see here I'm creating a policy based on the username, the policy string. I have to give it a name here. And then I create a duration for that. That duration in this scenario is actually 8 hours. So you can make it an hour to 36 hours. So I've chosen to give this person 8 hours access to S3 based on that policy that I've generated on the fly. I then create that session through a get federation token call. And then once I pass that session down, I can actually I create a temporary set of credentials, which I then pass down as a JSON object to the downstream client. So now the downstream client has their own access key ID, secret access key. They have an expiration field that they can see. So if you're a downstream client of this and you've just been given a set of credentials, you can see how long they're lasting for, and you can see when they expire. So if I were building a downstream app that used this service, I would then check, I would store that expiration date, and then 8 hours from now, I'd say, I'm going to need to get another one. And I could, underneath the covers inside my app, just sort of go back and authenticate again and quickly grab another token and swap it out for further calls. But my session lasts longer. And then I get the all-important token, which is a new credential that's been added as part of this service. Just for edification purposes, I've added the policy to this so you can see it, that it's coming back and what the policy looks like. And then I go ahead and I pass that back. So now the downstream client has access to that particular, has a set of credentials. Now the downstream client, of course, has to then, and I'll pop into that code really fast, the downstream client has to actually do a, sorry, this is some old flying that I was doing here, has to do a web request and then actually deserialize that JSON object that comes back and then use those set of credentials that have been returned. Now that I have a credential set, I can use that in further calls down in the, to say do list bucket now, or to say get an object. Now, as it turns out, the code to create the client you'll see here is only slightly different than how I would have created an S3 client previously. Now I can do a set of session credentials, session AWS credentials, instead of the basic AWS credentials that existed before. I can do a set of session ones, and I add now 3 fields to the constructor: the AWS access key ID, the secret access key, and the token. Right. So all 3 of those are actually then included in the request. The access key ID and the secret access key are used. The access key ID is included in the URL. The secret access key is used for the signing of the actual request. And then the token is actually embedded as an HTTP header in the actual request. So that's how those flow over the wire. And then now that I have that S3 client, every call I make is using this new set of credentials. All right. So what does this look like when you actually run it? Unfortunately, it's just not as exciting when you get to the actual demo part as the code is. But I'll show you quickly how this all plays out. So what I've got here is I've got a couple of different console windows that are running this sample code. And so I'll actually pull up really quickly. Here's my sample console app, but then here's my config. So you'll see what I've done is I've said, oh, the bucket I want to hit is mtavis STS demo, and the federated token service is this the WCF service called getTemporaryCred.service/getToken. Right, so that's the getToken call or method you saw earlier in the token service. So that's actually how that that is being called to get those credentials. So when this client starts up, it's going to go ahead and hit this federated token service to get a set of credentials, and then it's going to go off and start calling S3 and hit this this personal folders bucket that's defined in configuration. Now, interestingly enough, you probably noted that the server side also had the configuration for the bucket name. So the session proxy is actually assuming and embedding a specific bucket because it's actually a session proxy for that particular S3 bucket. You could have it be more generic than that, but in this scenario, if those 2 didn't match, so if this said mtavis-private or something, and the session proxy service said mtavis-STS demo, this wouldn't work because I'm trying to hit a bucket that is not included in the policies that are being generated by the actual session proxy. In this case, they do match, so it should work just fine. So let me show you quickly how that all plays out. So if I get rid of this configuration file, you'll see I can run the console app, and it goes ahead. Now, this first warning, I'll actually show that to you really fast. It says it's not running over HTTPS. This is actually a great warning. I've actually implemented this WCF service over plain HTTP. Obviously, this is generating credentials, handing them out. You want this to be over a secure connection. I've done this for simplicity's sake. I didn't want to go, generating a certificate, writing the code to sort of ignore any warnings around the certificate. So this scenario is just running over HTTP. But if this were a production rollout of this proxy service, session proxy service, then HTTPS would be not only recommended but strongly encouraged. And so then you'd be using SSL to encrypt those credentials. But as you can see, what I've done is printed out some of the things that come back. So I've received a token for enterprise DT/administrators. That's saying, hey, here's the Windows identity that was calling the service. So it actually does recognize that I'm the administrator. On top of that, then I hand back the new access key that's just been created, the secret key, which I've started out various bits to avoid you rushing off and calling S3 on my behalf. And then you'll see this really long string here. That's the token that was generated. That actually, so those 3 fields are the fields you use for creating that S3 client from an authentication perspective. And then, of course, on top of that, I've also shown you the policy that was generated. The policy in this case, you see that it's in a statement that it looks very similar to that policy fragment that was stored in AD that you saw earlier. The big difference is being that session proxy did substitute out and said, oh, the resource that I should be looking at is mtavis STS demo /administrator/star, right? So I've then restricted on the fly by doing substitution in the actual session proxy to only this folder that belongs to the account that called the service, right? And then on top of that, I also have the restricted to the bucket for listening. So I'll hit enter to continue. It'll then say, so this now is called S3, and it did a bucket list of contents for mtavis-STS demo. Obviously, you're maybe curious as to whether that's actually what's in mtavis-MTS demo, so I'm going to go back here and go to STS demo. It's one of my many folders, and you can see I have a couple of folders there. I've got an admin testing file, got a domain user file. So it's actually listing the contents properly. Now, as you can imagine, I can list out, because I have access to the administrator prefix or subfolder within it, I can list out this this text file that's in the administrator folder. You say, here obviously you see the, this is a test of the STS APIs tag. So that was the contents of that particular file. So that worked great. Now if I rerun this app and then decide to list out the domain user, domain user / domain user - testing .txt, you'll see that I get an access denied error right here because I don't have access to that folder. My policy only allows me access to the administrator subfolder. Now, previously I also launched another command window, but you'll see here in the title of the command window, it says running as enterprise DT / domain user. I did a run as to create that command window. So now I'm running as a different identity in the domain. So you can see immediately the token received is different, enterprise DC domain user. It has a different, obviously a different access key ID, a different secret key, a different token are all different. And the substitution is different in the policy down below. You'll see it says mtavis-STS demo / domain user. So all those things have changed based on a new identity coming in and a new session token being created. It, again, because it has general listing capabilities, lists everything in the bucket, but it can't see, it obviously can't access the administrator folder. But unlike the previous attempt from the administrator account, I should be able to list out the contents of the domain user files. So there you go. You can see it says this is a domain user file. This is a test of the STS APIs. So as you can see, that allows me to go ahead and generate specific policies based on user identities. And none of these users are IAM users. They only exist as a identity within Active Directory. So I've used that. I've authenticated against Active Directory. I've then turned around, generated a token on the fly to allow those users to hit S3 directly, and then restricted their access to subfolders specific to their usernames, and allowed them to be called from this client application. So this is one very, very simple example of how you can actually federate your Active Directory identities into IAM, and therefore use them to create credentials to call the AWS APIs directly. The one thing I'll obviously show you is in the web config, and I'll zip down. You pull down I'll have to change that. I'll have to change that secret key, and I'll have to rotate those keys because you saw those for a split second. But another approach for storing the actual policy statements is actually this example here, where keys are just stored in the web config. That's certainly another approach that can be used to store them in the web config. One note that's made in here is that actually this is just using a simple key name substitution. A more appropriate mechanism using, for example, Active Directory to tie these to the SID of the actual account identity to allow for tighter restriction and tighter mapping. Another approach to storing these could be actually to store them as files in S3 under access control. So there's lots of ways to store those bits of policies, but I should reiterate that there are obviously key bits of security data that you need to protect in whatever approach you take to vending them out. So we pop back to the presentation quickly. The one question obviously is asked a lot of times is, well, what support do you have for all these things across the platform? So you see this is an eye chart. I won't read obviously every square in it, but it highlights a lot of the various things. So as you can see, obviously everything is supported. On the left you have our services listings. and then along the various columns is different identity authentication authorization schemes and their support levels. This is obviously as of today, but this will obviously expand over time. So the only reason this is included here is to give you a sense of the current support level, but definitely keep checking back because more services will add support for this as it goes on, and obviously additional improvements such as resource level controls, things like that will get added as well. So you see, obviously, there's the AWS accounts are supported in every service. IAM users has a pretty broad support already across most of the actual services. Federated users is additional authentication and authorization code. So as you can see here, this is more focused. The initial launch is focused on S3, SNS, SQS, SimpleDB, and EC2, but that will obviously expand over time. So keep your eyes open. More and more things will be supported as we go along. And then, of course, there's different authentication mechanisms, session token being the one that is tied to the federated identity. So if you see session token support, it pretty much lines up with federated user support. And then, of course, there's different types of authorizations. Right now, most services have an action level authorization that are supporting IAM, which means they can support lockdown to specific APIs, but maybe not resource level. Resource level is actually restricted right now to things like S3, SNS, SQS. So that gives you a sense of the current support across the platform. But this chart is actually obviously just a snapshot in time. So if you're looking at this and it's any date beyond August 17th, then maybe you should double check with the actual documentation of the site just to make sure that we haven't added some more features or functionality over time. So with that, I thought I'd open it up to some questions that have come in from you during the webinar.
All right, thank you, Matt. So we're going to take a few questions from the audience. Please submit your questions now, and we will start with ones that have already been submitted. So we got a question here from Antonio. If I have a different template user with different group policies, if I want a federated user with a Rolito, do I need to create it with my template IAM user?
So I think the way to think about that is if you want to have a federated identity that has a certain level of access, then whatever IAM user you use to generate that identity has to have at least that level of access. So that's kind of the way to think about the relationship between those two. The IAM user that you use to create the tokens should have at least as much capability as any of the federated identities it's going to be creating through the session security token service. Anything you guys want to add to that?
Okay. Any other questions, folks? Feel free to type them into the question panel.
Did you guys have anything to add to the webinar? No? Okay.
Okay, it looks like we have a question here from Jim. If I understand correctly, this demo lets me federate between my AD identities and AWS to call AWS APIs, i.e. EC2, S3, etc. Do you plan to add support for federation to the AWS Management Console?
That's a great question. Anders, do you want to jump on that?
Yes, we are looking into this right now to see what we can do in this space. It's on our roadmap to be as part of an IAM release and a future release of IAM.
Right. So not now was the quick summary, but obviously, as I mentioned before, with that chart with all the checkboxes in it, these are things that we're going to continue to add over time. So having a federated identity for a console access would be a nice touch.
Okay. Any other questions, folks?
So the one thing I should point out, obviously, since I still have you here, is that this is one specific example. Obviously, Active Directory was a great place to start showing this. There's no reason why this approach could not be applied to a whole bunch of other different technologies. So, for example, you could have a session proxy that is sitting in front of an LDAP implementation as well. So it doesn't have to be just Active Directory, it could be Open LDAP or any of a variety of identity stores that exist out there. That's one approach. You could even imagine using this approach with already existing third-party identity stores. So like an OpenID, where somebody might authenticate against an OpenID, pass a token to your session service. You could authenticate that token and then use that as a way to generate identities against maybe OpenID identities that exist outside of your enterprise. So this isn't restricted, obviously, to Active Directory. That was an example we thought was commonly used, and certainly something where a lot of enterprises could quickly enable access for tens of thousands of employees with the minimum amount of work to create those accounts. So.
And it looks like we have one other kind of general question. What other use cases can this be applied to?
Wow. So I mean, that's we generally a lot of times build services and allow the imagination of the developers downstream to run wild. So feel free to think of other scenarios where you could use it. I think the ones that we know have been most in demand are obviously federation of enterprise identity stores. So Active Directory, LDAP identity stores inside the enterprise. Another common scenario, so let's say, for example, you build a mobile application and you want to allow people in that mobile app to upload pictures to S3 directly. But you don't really want to give them free license, forever to go ahead and continue to upload pictures from their phone directly to S3. So instead, what you might do is actually have the client application inside of the mobile app, do some authentication against your website to say, hey, is this user still valid? Do they still have an account? Yes. Okay. Vend them a token on the fly that they can use to then upload pictures from their phone directly into S3. So that's another example of where you can vend an identity or a set of credentials for a short period of time to enable a mobile user who might be a temporary user or a long-term user, but somebody who you want to authenticate on a regular basis using your authentication mechanisms as opposed to AWS. So mobile is definitely a common one. Consumer web applications could be the same approach as well. Very similar. Log into website X, authenticate there, get tokens handed down through the interface, and then allow them to upload directly to S3 or S2S or SimpleDB. You could hit any fundamental services that support the federated identity credential set.
Thank you. Any other last thoughts or comments before we wrap up? Well, that wraps up today's presentation. Thank you, Matt, and thank you to everyone for attending today's webinar. Those who attended today's webinar will receive a follow-up email with a link to this recorded presentation. And I encourage all of you guys to peer